Today we're going to look at average rates of change. Now let's just talk about constant rates and variable rates. If a constant rate means it's changing at a constant rate, we're going to look at average rates of change. So there's a couple of types of rates of change you may have already studied. For example, if I'm filling a container and I look at the height of that container over a period of time, if the rate of change is constant, you see a straight line where the gradient of this straight line gives us the rate at which that volume is changing, the height of the water is changing over time. You can get variable rates as well, where it's not so easy to work out that rate at the moment. We haven't got a formula here. The gradient's nice and easy. To work out the gradient of this, we can literally do rise over run. And you work out the difference between the vertical height over the difference between the horizontal height. But on this one, it's not so easy to do. So we could work out what we call the average rate of change. So you'd still pick 2 points and you would look at the coordinates and you would just be working out the average change. So the vertical height divided by the horizontal height, the horizontal distance, and that would give you what we call the average rate of change. Average rate of change is basically finding the gradient between 2 points. So you may have seen the formula y2 minus y1 over x2 minus x1, where the first coordinate here, for argument's sake, is x1, y1, and the second coordinate here is x2, y2. And so you'd use the formula. Same with this one here. This could be a coordinate x1, y1, and this could be the coordinate x2, y2, and you'd work out what that average rate of change is between those 2 points. So let's do a couple of examples. I'm going to do a couple here. One where I'm going to read the average rate of change from the graph, and another where I'm going to do it from a polynomial. So looking at this one, we've got two coordinates p and q. We'll call this one our first coordinate and this one our second coordinate. So using the formula y2 minus y1 over x2 minus x1, all I've got to do is substitute the values in. So the second y coordinate is 48, the first y coordinate is 30, over, and in this case I've got 7 for the second x coordinate and 2 for the first x coordinate. So 48 minus 30 is 18, 7 take away the 2 is 5, and we get 3.6 as our average rate of change. Now looking at this one, if I have a look at this function, I've got to find how it changes from x is 1 to 5. So the first thing I've got to do is find out, well, what is f of 1 and what is f of 5? So I'm going to substitute x is 1 into this polynomial, and I get 1 squared is 1, take away 2, plus the 1, take 2, plus the 5 is 4. Now let's work out f of 5. So I've got 5 squared, take 2 lots of 5 plus 5. 5 squared is 25, minus 10, plus the 5 is 20. Now, this is actually going to be my y value because it's f of x, isn't it? So these are my first y coordinate, my second y coordinate, or y value, apologies. And my first x value was 1 and my second x value was 5. So applying that to the formula, we end up getting that average rate of change is 20 take 4 over 5 take 1, which is 16 divided by 4. Obviously, I'd normally write underneath, apologies. 16 divided by 4, so the answer is 4. You don't normally write equals in a long line, it would be underneath, of course. So the average rate of change is 4 between when x is 1 and 5. So just to summarise, average rate of change is always between 2 points. Certain averages that you may have worked out are average growth of a tree, or it could be average speed, where you take the distance and divide it by the time. These are all common average rates of change.